Assalamualaikum and hi to everyone. My name is Muhammad Shakir bin Rosli and today I will be discuss an essential in situ geotechnical investigation method which is the pressure meter test or PMT. The pressure meter test is a sophisticated field test used to determine the deformation and strength properties of soil directly in the ground. Unlike some lab tests, it allows us to evaluate soil stiffness and bearing capacity in its natural undisturbed state. The first part is equipment and components. Let's look at what makes up a pressure meter. The system consists of three primary parts. The first part is the probe. This is a cylindrical tool that we lower into the ground. The second part is the control unit. This sits at the surface and manages the pressure and volume measurement. And the last part is connection tubes and rods. This link the surface unit to the probe underground to transmit the pressure and data. If you look at if you look at the diagram, the probe itself often features a measuring cell flanked by two guard cells. The guard cells ensure that the expansion of the measuring cell is strictly radial, creating a controlled cylindrical cavity expansion. Next is working principle and procedure. How do we actually perform the test? It follows a clear four-step process. The first step is insertion. First, we drill a borehole. It is critical that the hole is clean and only slightly larger than the probe, which is specifically less than 10% larger. The second step is the initial contact. The probe is lowered to the test depth and we begin to apply pressure to make contact with the borehole walls. The third step is expansion. Pressure is increased in control step. As the internal pressure rises, the expandable cylindrical membrane pushes against the soil. And the last step is measurement. For every pressure step, we record the corresponding volume increase or radial strain. Essentially, the soil resistance to this expansion tells us how strong and stiff it is. For the graph, the pressure volume curve and the theory, the data we collect is plotted on a typical pressure volume curve. There are three key phases shown on this graph, and the first one is closure pressure. This is the pressure required to push the probe against the borehole wall and re-establish the original in situ state. The second key phase is elastic range. This is the linear portion of the curve where the soil deforms elastically. From this slope, we calculate the pressure meter modulus. And the last key phase is limit pressure. This is the point where the soil reaches a state of failure or continuous plastic deformation. So for formula and calculation, to turn our field data into engineering design values, we use specific formulas. To find soil stiffness, we calculate the pressure modulus using the ratio of change in pressure, delta P, to the relative change in volume, which is delta volume over V naught. For strength, we can determine the underlying shear strength using the limit pressure and closure pressure values. We can also find the coefficient of a pressure at rest, K naught, which help us to understand the horizontal stress in the ground. In a sample calculation, if we have a volume change of 60 centimeter cubic at a pressure change of 150 kilopascal, we can determine a modulus of 3,325 kilopascal. This is a diagram of pressure meter test. To wrap up, why do we use the pressure meter test? It is considered one of the best tests for fine-grained soils. It provides higher and often more realistic values for shear strength compared to standard triaxial lab tests. Most importantly, it gives engineers the essential for designing foundation, assessing bearing capacity, and estimating how much a structure might settle over time. I think that's all from me. Thank you.